Welcome all. I'm Steffen Zschaler. I'm at King's College in London. I'm also directing MDENet. And today I'm hoping to tell you a little bit about the education platform that we've been building and walk you through how you can use it to build assignments and learning activities for your students who want to learn about MDE. So what am I, what's the sort of plan? Before I do that, perhaps I should say, as I do this, there's a multitude of windows open on my screen to try and help me step you through the various steps, which however means that I'll probably won't see the Teams window at any given time, or if anybody wants to raise a question or anything like that. So Nuno, I think, is going to monitor the chat and any hands that anybody wants to raise, etc. So he'll interrupt me if something comes up that feels like it needs to be answered in the moment. And alternatively, also feel free to put questions on the chat and to sort of mark them for the Q&A at the end, and we can pick them up at that point. But I'll sort of be, relying on, I think, on Nuno to shout at the right moment. So if you can indicate to him whether you feel you have a question that ideally needs to be responded to more or less straight away, or whether it's a question that can stay put until the Q&A at the end, then that'll help him coordinate that. Right, so what am I going to talk about? I'm going to start by giving you a sort of a brief introduction to what this education platform thing actually is, and why we created it, what kind of sort of the main goals of it were, and then we're going to delve right in, and I'm sort of hoping for this to be a reasonably practical session where we actually build a concrete assignment together, and I kind of walk you through the steps. So building it together is perhaps an overstatement. I'll mainly be walking you through the steps, I think, of doing it and talking you through that. And we'll start actually by setting up a GitHub Classroom in the back end, so that we have somewhere for our code to go and an easy way for sharing that code with students. And then from there we'll build initially a simple first activity which allows students to create an Xtext editor in their browser, and then we'll take a next step and extend that and combine it with a different MDE tool. And I've chosen ETL, the Epsilon Transformation Language tool, to combine it with, and I'll show you how you can put these together and make it work in the browser quite easily. And then we'll have some time for Q&A. And then as we do this, I'll touch on various little bits and bobs that are helpful and useful if you're building these activities for the platform, and that'll make your life easier. Right, so let's get stuck in. What is this education platform? The challenge I think that many of us face as they're trying to teach MDE is that MDE tools are great, but they're also really complicated, and in particular they can be very difficult to install and configure and make work together. And while we've all kind of gotten used to this, our students haven't, and it tends to create challenges where they actually just struggle to get their environment set up and don't quite get to the point, and it distracts from them learning the key point that we want to bring across, which is how MDE works and what the key ideas are in MDE and so on. And so that's one challenge. The other challenge is they're quite powerful. They can do lots of things. And so if you open your IDE with some Eclipse tools installed, you've got lots of toolbars and buttons and things that you could do, not all of which are relevant to the task at hand. And again, once you know a particular MDE tool, you know which bits and bobs are relevant and which aren't, but our students don't. And so it becomes really difficult for them, if we set them a learning activity, to work out what's the thing that I should actually be focusing on, and what's the next thing that I should be doing, and what are all these other things, and which can I ignore and which do I have to know about. And so we set out to help address that and make our lives a little bit easier by building the MDENet Education Platform. And this nice little QR code here will send you to the sort of GitHub repo for that, and give you a sort of initial idea of what it's all about. Which is an online platform, so it runs in people's browsers. There's no installation and configuration for the students. It uses a playground metaphor. In fact, it is a sort of derived originally from the Epsilon playground. But the key thing here is that when we build learning activities on this platform, we limit what the students can do. And so that provides them clarity, right? It goes away from this challenge of there's so many things that I could do, which ones are the ones that I should be doing, because we only give them access to the activities that are the actions that they should be doing as part of the activity. It's backed by a GitHub repository, so every activity that they do is backed by a GitHub repository, and that means you can set it up so that they can clone that repository onto their machine and then use it in a standard IDE with the actual real MDE tool. And so that provides a pathway for students out of the playground into the sort of real tool world as well. And I feel that that's quite important to provide that link so that they don't just learn in this very simplified world of the education platform, but they can also then start seeing how it connects to the real world. And for the teacher, we provide a way of declaratively describing learning activities, and so that makes it fairly easy to define new activities and to share them with colleagues and so on as well, because you've got a file that says this is what the activity is, this is how I'm using the platform. So the platform is fairly highly configurable as a result of that as well. And finally, the platform, I think of it as a community project. We have a community steering board. Always very happy for other people to jump in and join in and say we need to do this or that, and I think this is important because it shouldn't be a tool that's just for us here at King's or even just for the few people who are on this community steering board, but that's available for everybody who wants to teach MD, accessible to everybody who wants to teach MD. So that's sort of the general idea. Here is an example of what it looks like, and in fact, this is sort of our goal for today. Is going to be to use the education platform to build an activity on there that allows us to do this. And what this is you can see here. Let me see whether I can convince my. There we go. You can see here this runs in the browser. On the left hand side, we've got a sort of standard kind of menu kind of thing where we've got the list of the different activities that are currently available to the student. And we've got a save button, which allows the student any changes that they've made anywhere over here. It allows them to save that back into the underlying repository as a commit. So they can actually do stuff here, save their work, come back to it, or clone it from the repository later, and they can kind of go back and forth between those different modes as they wish. And then over here in the main part over here, we've got various what we call panels available that form the different steps and different parts of the activity. And because this is a playground, the students literally only see the bits that they should be focusing on. In this case, what they're seeing is a panel up here that gives them access to the specific modeling language that they've actually been developing in the previous step, and that allows them to try this out. There's a panel over here that allows them to access various visualizations of this modeling language. So there's a way of visualizing the meta model in here, but there's also a way, and that's what we're currently seeing here, of visualizing the actual model that they have here as an object diagram in this panel. And then they have a panel here where they can write code in the Epsilon transformation language, and they can run that. And if they run that, then they can down here they can see again a visualization of the resulting model, and so that allows them to also compare this really easily with the source model and kind of see the changes that the transformation has affected. And then finally, there's a console panel here down here, which allows them to debug their transformation, which is what we've done here, where we've just added some print line statements into the transformation code, and we see that in here, but also allows them to see any error messages, for example, from ETL as it tries to execute this, and maybe if they made a mistake in writing it, then they'll see those error messages stand out. And so that's what we've configured it for this activity. For another activity, the platform might look completely different, because we might combine lots of other panels and lots of other tools together for a particular activity, and that's kind of the power of these sort of declarative descriptions that I've mentioned. So what we're going to try and do today is what I'm going to try and do today is talk you through how one would go about building this sort of assignment, this sort of activity with the MDENet Education Platform. So let's start on that. So the first thing I want to do is set up some infrastructure for us. And what I'm going to do is I'm going to set up a classroom in GitHub Classroom. And perhaps actually what I'm going to do is thumbs up this comment. You have used GitHub class. So I'm going to put a comment on the chat, and if you can add a thumbs up reaction to that, if you've used GitHub Classroom before, that'll give me a sense roughly for how careful I need to be in my explanations. I'm hoping that you can all see the chat and actually add emotion reactions there. So this is over to you. Everybody busily finding their chat. Okay, so either I'm talking into the void, or indeed nobody has used GitHub Classroom before. I'm going to assume it's the latter. So I'm going to explain this a little bit more carefully then. So GitHub Classroom is a thing on GitHub that allows you to set up a repository as a template and then share it with your students. And what you actually share with your students is you give them an invitation link. And when they click on that invitation link, GitHub creates a copy of the initial repository that you've provided and makes it a repository for that student. Those repositories live in an organization that you set up specifically for this particular classroom, and you're the owner of the organization, and that means you will also have access to all of your students' code, and so you can give feedback on that and so on and so forth as well, quite easily. In theory, GitHub Classroom also integrates with standard sort of VLE systems like Moodle and Blackboard and so on. In practice, certainly the last time I tried this, it was a little challenging to get to work, shall we say. So I've sort of not used that particular integration too much. I tend to just share the invite link with my students. To set this up, what do I have to do? Well, I've got to go into my browser here. Let's see. And we're going to go to classroom.github.com. Sign in. And I'm going to create a new classroom for this. So we're going to create this new classroom. And as you see, if I want to create a new classroom, I actually need to pick the organization that underpins that classroom. So in fact, I first have to create such an organization. So let me do that. So I go to GitHub, create a new organization. Don't want to pay for it. We're going to call this education platform demo for now, and I'm going to put my email address. I think that's pretty much it, and that'll get set up. And I'm not going to add any users to this for now. Okay, so I've got my organization. This is on the free tier by default, but because I'm using this in an education setting, I'm actually going to upgrade it briefly. So if I go to GitHub education.github.com, I can ask to upgrade this organization to the team layer, which allows me to have private repos and actually in particular gives me a bit more power for running actions and things like that, which is useful for auto grading. So I tend to just do that by default. So now I've got my organization ready. So now I can go back to where I was creating this GitHub classroom. By the way, please do shout at me if I run too fast or go too slowly. So I'm going to create this GitHub classroom. I'm just going to reload this page on hope that that allows GitHub to find this new organization that we've just set up. There we go. There it is. We're going to select that. And we've got this new classroom. We're not going to enable code spaces in here. We don't need it for our purposes today because we're going to use the education platform. Not entirely sure why it insists on adding a random number there, but we're just going to create a more human readable name. And we're going to go, yes, we're not inviting TAs today. And we're not going to connect to a roster. So there's our new classroom. Okay, and the key thing is in a classroom is that we're going to be creating assignments that are backed by this repository, and the repository is what GitHub Classroom then hands out to students as they accept invitations. But because we obviously haven't got a repository yet, we can't create an assignment yet. But what we can do, and that's an important first step to allow the education platform to work, is we can install the GitHub app for the education platform in our organization. Okay, so what this will do is it will allow the education platform to access any repositories that live in that organization, including in particular the repositories that the students define, but also the repositories that we define, even if they're private repositories. And it'll allow the education platform to write back into those repositories, assuming, of course, that whoever uses the education platform at the time actually has write access on any given repository. To install the GitHub app, again, this QR code here will send you to the appropriate link. I'm also going to paste that link into the Teams chat here. I'm going to go to it in a moment. I need to paste it in the Teams chat. Thank you, Perdita. By the way, I've just seen that on the chat. You've added the negative of my question, which I probably should have done as well. To be clearer, so this link that I've just posted, if you go to this link, then that will allow you to install the GitHub Education app. The MDENet Education Platform GitHub app in your organization. So this is the page that you will get, and you'll see this is about the MDENet Education Platform KCL, because it's the one that it's actually for the instance of the education platform that's currently hosted by KCL. And you'll see the MDENet logo here. And what we're going to do is we're going to navigate to our organization here, wherever it's found. There it is there. We're going to say install it there, and we're going to say provided access to all repositories in this organization. That includes future repositories in that organization, and it will have read access to metadata, but it will also be able to write code in those repositories, because when the student clicks on save, the education platform should be able to create a commit in the repository, assuming that the student has access to the specific repository that they're trying to save to. So it doesn't give students access to arbitrary or anybody access to arbitrary repositories in the organization. It only gives them access to those repositories that they actually have access to, but it makes sure that they can do that through the education platform. Okay, so we're going to click on install and authorize, and that'll actually send us to the education platform, who will go, I'm not quite sure what you want. They look a little weird. I guess I've got to log in properly and type in an authentication code here. Hang on. Am I there? So this is the education platform going, you haven't told me what the activity should be, because the setup process sends it to the standard education platform. But actually, that's also saying it's now installed in that organization, and we can check this by going to our organization, going to settings, going to GitHub apps down here, where we see that the app is now installed in our organization. Right. So again, what this does is it gives the education platform, the online platform, access to all the repositories, and then the student in a later step, students will have to actually authenticate rather with GitHub, and that will provide authorization for a specific repository. And so this is sort of all we have to do in terms of getting the classroom set up. What we're going to do now is we're going to create a repository that will contain the code that our students need for this activity. And I'm going to cheat a little bit with this, because what I'm going to do actually is I'm going to go and use one that I made earlier. I've got a repository here that contains code for that's needed for this activity, right? So you can see it contains some Eclipse projects here that are in fact sort of an Xtext language. There's a short example folder here with an example file in it, and there's a sort of a bit of a Maven setup. And in fact, I think I've actually even got a sort of auto grading script here that'll run certain tests over the student code eventually to give them some feedback. What I'm going to do with this is, so that's typically what I do when I create these activities. I'll have a repository somewhere, and but for it to be usable in the GitHub Classroom, I need to put the repository into the organization that underpins the GitHub Classroom. And one way of doing this, one fairly easy way of doing that, is just to create a fork in that organization. So I'm going to do that. I'm going to fork this repository, and I'm going to stick it into our EP demo organization. I might just copy the main branch, or I might do a full fork. In this case, it doesn't make much of a difference. I'm going to create this fork. And so at this point, what I have is I actually have my first repository in this organization here, and it's a private repository as well, which is going to be important, because obviously I might end up putting some of the solution code in here already, so I can check it easily. And I don't want my students to see that, or to edit that or access this repository in any way. So I'll keep it private so that only I, or possibly any other people who I teach with, have access to it. What did I want to do next? So one thing I wanted to say is this original repository that I have here is something I would have created, opening an Eclipse and setting up Xtext and doing all these things in the usual way, using the standard tools. And so I get this sort of structure that comes out directly out of Xtext here in this case. But that's exactly the thing I was saying at the beginning. This will allow students to clone their own repository down onto their machine, and also open it in Eclipse if they want to, and actually work with the real tools as well as accessing it through the platform. At this point, the repository as it stands isn't yet accessible by the platform. So what we need to do next is to provide some activities. Okay. What I'm going to do first, though, is one thing I always keep forgetting is I'm gonna just, because I've created a fork, I'm gonna have to enable GitHub Actions, and that's important because I have an autograder action here that runs, and I want to make sure that that will actually run when my students clone the repository. Okay, so with this repository, we can now set up our initial activity. So let's do that. In order to be able to do that, our repository needs to be what's called a template repository. All that means is GitHub has a way that's not forking for creating stamping out new repositories out of this repository, and these new repositories will only contain the latest commit from our source repository, from the template repository. And so that means I can do whatever I want in this repository, and then I give the invite link to the students, and they'll only get something that shows the latest link. And so, for example, I could even have the solutions in this repository already, and as long as I remember at the very end to wipe them out from the repository, the students won't be able to back access them. So now I can go to my GitHub Classroom here, and I can create an assignment here. I'm going to give this a title, Xtext and ETL, for example. It's an individual assignment. I'm going to say that the repositories that we're going to create for students are private repositories. And then I can decide whether my students should be able to delete and mess about with their repositories, or whether I'd rather they don't. And that's what this tick box is about. For today, it doesn't matter much, so I'm going to just leave it as is. And then I'm going to say, what is that starting repository? Well, it's epdemo/epdemo. That's the repository that we just created, and this is a template repository. And I'm done with this step. And then here I could set up auto grading from the web, but actually I've already put that into a workflow directly in the repository, so I'm not worrying about this here. And we're going to create the assignment. And now the assignment is ready, and then I've got this URL as the URL that I would now share with my students. And I'm going to show you in a little while what happens when the students click on that. But before we do that, I want to set up the assignment ready for use with the education platform. Okay, right. So we've done all of these things. Now let's start building the basic activity. Okay, to this end, I'm going to clone my repository onto my machine. And boom. And clone this. Thank you. And we're going to open this in VS Code. Now we've got this whole thing here in VS Code, and we can start building our activity. Have I forgotten any other steps? Let me just make sure that I haven't forgotten anything. I think we're fine. So we need to start creating this activity, right? So let's start that. To do that, there's a few things that we will want to do. I'm going to talk you briefly through what are the key parts of an activity. I'm going to then briefly show you the VS Code extension that you can use to edit activities in VS Code a little bit more conveniently, and then we're going to actually start building our activity. Okay. So what are the key parts of an activity? There are really 4 key elements. The first part, apart from giving it a name and things like that, but the first part is tool imports. So the way the platform works is that it allows you to combine together different MDE tools into an activity, as long as the providers of those MDE tools have built a little wrapper around their tool, which makes the tool accessible from a web API. And what they have to do is they provide this web API, and then they provide a small JSON specification that sort of says these are the things that you can actually use from this tool as part of the platform. So when you define an activity, you've got to say what tools am I going to use in this activity, and where can you find the web API for those tools. At the moment, for the current running platform, we're currently hosting all of the tools for which we have support directly at King's, but that's not a necessity. They could be hosted somewhere else, and you could then still combine them in your activities. The second part is you've got to define what are the panels that the student can interact with, and what are the files that show up in those panels, and the types of information that's in the panel, and so on and so forth. And what are the buttons available on those panels, etc. You then define layout. So that's basically about saying which of those panels are actually visible to the student and where do they go on the screen. And finally, you define actions, which is about when the student presses a particular button, what's going to happen. If you check out the QR code on the right here, that will take you to a wiki that we have that explains all of this in more detail and provides a fair amount of documentation for how to create activities. Okay, now let's actually. Oh no! So yes, in order to make your life a little easier, there's a VS Code extension which provides a little bit of basic sort of code completion and a little bit of syntax checking. Basically, what it does is the activity specification is given as a JSON file, and there's a schema for that JSON file, and the VS Code extension makes sure that whatever you write is sort of checked against the JSON file. So it's not perfect. In particular, it doesn't support provide great support for checking cross references within the activity file. So you've still got to be a bit careful there. But it's at least a sensible start. And if you check out this URL here, that's the repository for it. And in fact, if you click on the QR code, that'll get you to the releases page of that. So let me just show you that briefly. So where it'll get you is here. And if you take this VSIX file here, that's the actual packaged extension. You can just go to your Visual Studio Code, go to where is it, the extensions tab, and you can drag and drop the extension, the VSIX file onto there, and that will install it. And you can see it's sort of here. I already have it installed in my VS Code. This should always be up to date with the latest version of the schema tile. So it's access them, downloads them fresh every time directly, so they're not directly embedded in the extension. So if we make any fixes to those schemata, you should get them directly into your extension as well. Okay, well, that's the VS Code extension. Now I think all that remains is actually going to start and build the activity. So all that, I go here. Activities, as I said, are defined in JSON files. I tend to put these directly into the root of my repository, but there's no reason why you couldn't put them somewhere else. In fact, if you look at in some of the examples that we provide in one of our repositories, they actually have different activity files and different subdirectories. But I'm going to create this here, and in order to use the VS Code extension, my file name needs to end on activity and then say .json. You can, in principle, also write YAML files. The platform also supports YAML files. Our VS Code extension doesn't yet actually check the YAML files. So for the VS Code extension, it's easier to have the JSON file. Okay, so let's get going. There can be more than one activity. So the first thing we do is we create this activities array, and within that we create an object for our activity. Now, we're actually going to define two activities because we're going to want our students to be able to create Xtext editors. And that means they have got to have one activity where they define the grammar, and then they're going to have another activity where they use the Xtext editor, the editor that Xtext generates from the grammar, and they can try it out and they can play with it. And so we're going to define two separate activities here already. And then obviously the first thing we need to do is we need to kind of say, okay, what will these activities look like in the menu on the left-hand side? What will the student see? Okay. And so to that end, we're going to give them an ID and a title and an icon. I'm just going to, rather than type everything out, I'm going to copy some bits and pieces in here. And I'm going to explain that in a moment as well. So what I've done is I've given them IDs. These IDs are really just for use internally in this file, right? And they should be unique. They're useful because they allow me to cross-reference between activities and that sort of say that activity over there is the one that has the editor generated from this activity, and that's helpful for the platform to manage the menu and to know what's going on. The title is what actually goes into the menu, and so that's what the student sees, and so is the icon. And you note that I'm not actually putting an image file here. I'm just putting a label, and the platform comes with a set of sort of predefined icons that are sort of available through the CSS that you can use. And I believe there's documentation as well for what these are. And if there isn't, then we should probably add it at some point. So this is sort of the basic stuff defined, but it actually doesn't do anything yet, right? So the next thing I said that we need to do is we need to say, what are the tools that we're going to use? We do that by providing a tool statement here, which is an array of URLs. And those URLs, as you will see, they link to specific JSON files again. Okay. Obviously, in order to be able to do that, you will need to know where the tools are deployed. If you go to the wiki page that documents how to create activities, you'll find a list of these various URLs for the different tools that are directly available on the current education platform. And if there's a tool that's not available on there, but that maybe somebody else makes available, then obviously you would need to talk to them to find out what the appropriate URL is. If people watch this video after today, you may find that this top-level domain name will change in the not-too-distant future, and it will actually be a subdomain name under mdnetwork.org. But for the moment, we've got to still live with this slightly more complicated domain name. So what all this does is it tells the education platform what tools we're going to use, and therefore it tells it also what types of panels and actions will actually be available in principle, so that and what we can use to sort of set up the whole activity, right? And so the next thing that we're going to do is we're going to say, okay, let's add some panels to our activity here, and what we want is we want a panel that allows the student to write their Xtext grammar, and we will also add a console panel underneath that allows the student to see any output from generating the editor. So when they actually say, I want to produce the editor from my grammar, Xtext will produce output, and it might in fact produce error messages and so this console panel will allow the student to see those error messages, right? So we're going to have, again, two panels here. And the first panel we will say is xtext panel. So you can put whatever you like here in these IDs. Again, I tend to label them panel dash something, but really it's up to you what you want to do there. Again, we're going to give them a name, which is so this is what will actually go into the title bar of the panel on the platform. So this is what the students will see. So you can put arbitrary instructions here if you wanted to, as long as they're not too long to fit into the title bar. And then we provide what's called a ref. And this is actually defining the type of panel that this is. And the types of panel are made available by these tools. Okay, so these tools will make different types of panels available, and that a type of panel comes with things like syntax highlighting for that language, or basic code completion for that for that tool and that language, and things like that. But it also comes with a set of default buttons that are already available as part of the panel. Okay, so the panel that we want to use here is a panel that allows us to write an xtext grammar, and so this tool here defines that. So in fact, if you're unsure about what panels are available, you can always actually load this particular URL and look at the JSON file, and you'll be able to work out from there what panels and what functions and capabilities are in fact available. And then we need to say, what are we actually going to put into the panel? What's the file? And remember, I said our repository can have an arbitrary structure. In fact, we've got this huge, complicated xtext plugin project structure that we set up there. But the student really only cares about one file, which is the grammar file. And so what we're going to do here is we're going to say that's the only file that we're going to show this student, and that we're going to allow the student to edit. And we do that by putting the path to that file in here. And that path needs to be relative to the path of where this activity file lives. Okay. And so if you look at this, so this is if I go in here, I then get my source and blah blah blah, and somewhere there I've got my turtles.xtext file. Okay, and that's the grammar file for my student. And actually, in this particular activity, I'm already giving them a full grammar file. Okay, and as we run this activity later, we'll be able to see that actually, yes, that's the grammar file that shows up in that file. Okay, there's two more bits that we will end up adding to this panel definition, but I'll talk about them in a little moment. Before I do that, I just want to also define the definition, add the definition for our console panel here. And I'm going to add a little bit in our other activity in a moment. Okay, so the console panel follows the same principle. It's got an ID, a unique ID. It's got something to put on the website, and the reference for it is console. Console is actually a type of panel that the platform defines by default, so that's not defined by the xtext tool. But you don't have to import a tool. It's just available to you at any given time. As I said, I'm going to down here add one panel already, and that's the panel that we're going to use to edit files, edit models in our language, right? And so we're building a turtles language. So I'm calling this panel turtles. I'm saying try out your language here. It's an xtext editor. We'll get to that type of panel in a moment. And the file that we're loading is in this example folder, the test turtles file. And yes, it's the extension turtles. Xtext needs that to work out what's going on. And you've noticed that I've created this panel in this second activity, because what we're going to do is we're going to want to say, when you generate an editor from this grammar, you should now make this activity available, and this panel here should be the panel that uses the language that comes from here. Okay, and we do that by adding two more statements to the definition of this panel up here. Namely, Again, I'm going to copy those in for ease of reference. I'm going to say the target activity, as it were, the activity that contains the generated editor, is this activity down here, and the panel within that activity that is the generated one is this panel down here. Okay. So this is the definition of our panels for our first activity. If we left it at that, those panels would not show. So the next thing we need to do is we need to actually make it so that those panels show. So we define a layout. And actually, let me just copy that in rather than typing it out in the interest of time. And the layout is sort of a two-dimensional array that allows us to say visually where do the panels go. Okay, so everything that's in one of these goes into the same row, and then each of those becomes a new row. So what we're saying here is we're going to have our grammar panel at the top, and underneath we're going to have the console panel. Okay. Now, so far we've defined what our activity looks like, but we haven't yet defined what happens when the user presses, when the student presses a particular button. Now, this xtext grammar panel already comes by default with the little run button that the student can click on, and that will trigger the generation of the xtext editor. The tool defines a specific function, a specific web endpoint that will run that generation. But what we still have to say is what are the files, what are the inputs to that function, and what do we do with the outputs? Okay, and that's what we use the actions block, the final building block in our activity definition for. And so what we're going to do here is for every button that we want to be usable, we're going to say what are the inputs and what are the outputs of for that button. Okay, and so we're going to create exactly one action for this activity, which is the one that takes that links to this little run button. And so the first thing we've got to say, we've got to identify which button we're talking about, and we do that by providing a source panel. And the name of the source button. So again, in order to find out what the button is called, you can look at this JSON file and it'll tell you what the ID of that button is. In this case, it's called the somewhat unimaginatively called action button. And then we provide a set of parameters. So say this is what actually we send to it, and we say where to send the output. Okay. Now, in the case of generating an editor, the main output really is the generated editor and enabling the second activity for that. But there's a secondary output, which is sort of any progress messages, anything that goes in standard out or standard error that the student needs to see to know that everything's going well or to be informed of any errors. And that's really what we're talking about in this case here. And so we want to send that to the console panel. So really, we're saying where to send the output rather than what the output is, if that makes sense. So we're saying any output, any of these messages go to this console panel and are to be displayed there. And then the parameters, again, if you look at this JSON file, you'll find what parameters are defined. And then, or equally, if you look at the online documentation of the tool, of course, as well. And then you can say, okay, what are therefore the concrete values for those parameters? Okay, and so these are the main parameters that we need to provide. We need to provide a language name and a base name. So this is standard xtext stuff. Xtext defines projects around a base name for the project and a full name for the language, which is needs to be a fully qualified Java class identifier. We need to provide the file extension that xtext should use for files in our language. That's all the information that xtext needs to basically generate something. And then we need to say, what's the grammar for this language? And you will note that here, other than for the other parameters, we just give the information directly as a string. But for the grammar, we actually reference this xtext panel. And what that does is that the platform will take whatever is currently in that panel, whatever the student has typed in there, and it will give that to the xtext function, say, that's your grammar, go away and do stuff with it. The xtext tool is also able to take in code for a code generator, a scope provider, or a validation class. And integrate that into the generated xtext editor, but we're not going to do that in today's activity. Okay, so this is this, and then just to make this complete before we try it out, I'm going to also do a little bit more down here and complete the second activity a little bit. And I'm going to start by copying in the tool definitions that we're going to the tools that we're going to be using. Now, by now, hopefully, this part of the tool definitions, tool specification here makes sense. That's just bringing in different types of tools, right? In particular, we're going to bring in the epsilon tools because we need them later when we're going to do ETL, and I've just put them in here already. And we're going to bring in two tools that allow us to manipulate basic EMF files and to manipulate emphatic. Again, that's sort of used indirectly to do some visualization stuff. This one here looks a little bit weird, but it's also essentially a URL for a tool definition, except it's a URL for a tool definition that will only get generated as the students undertake the activity. And in particular, when they generate an editor from their xtext grammar, that will also generate a new tool definition, which will allow our activity down here to access additional capabilities around that language. Okay, and the trick then here is that we use panel turtles, which is the name of this the idea of this panel, and in fact, in particular, the idea of this editor panel that we've defined here as the target panel for the editor, and we prefix it with ID and use this sort of template replace notation around it. And what the platform will do when it sees that, it'll go, okay, when I generate an editor, then that will produce a bespoke URL for that student running that activity, which allows the platform to access that generated editor, and it'll put that URL in here as well, so that we can then load this additional tool definition file, and that's how it sort of interprets this. Okay, and let me see. The other thing I'm going to do is I'm going to add a little. So I'm going to add a few more panels to my list here. I'm going to talk you through those. I'm going to add a panel diagram, which we're going to use to show some diagrams. In particular, we're going to use it to show a diagram of the meta model and a diagram of the model. And this is an EMF graph diagram, so that comes from the EMF tool, and that's a tool that allows us to show arbitrary diagrams, basically. And I'm going to add a meta model panel, which is an eQual diagram, and that will load the meta model that was generated from the xtext grammar. And again, you will see that we're using this rewriting capability to access the generated tool and the meta model file that it offers. This is new. Here we're in defining this panel, we're actually saying we're defining an additional button for it. And we're using this action function thing to link it to a backend API. And again, in fact, in this case, I think this comes from the EMF tool. In this case, this function. And what that will do is it'll define a little extra button in this diagram panel that the students can click on to generate to load the meta model diagram into this panel. Okay, and so now we need to say, what are we actually going to show to the students? So we're going to define our layout. And importantly, we're actually only going to show them the turtles panel. So that's the editor for our language. And we're going to put next to this, help if I actually did this, the diagram panel. But we're not going to show them the meta model panel. So you could ask, why are we even defining this panel if we're not going to show it? The reason is that this is a really easy way to tell the platform to load this particular file and to tell the platform that the type of this particular file is that it's an equal file. And that will help it to sort of run, allow us to run functions over it and to use it in various interesting and exciting ways, which we're going to do in a moment. But it will mean the students don't have to actually see the XML that is the internal representation of an equal file, which would confuse them. So we're going to also define our actions, which is, again, remember that that's about saying when somebody presses a button, we already know what the function is that's going to be called, but we need to say what the inputs and outputs will be. And I guess one thing that I've forgotten, I wanted to also add to this panel here, I wanted to also add a button that will allow us to sort of generate a diagram for the model, basically. And that button already exists in the turtles in the xtext editor panel. But there's also some other buttons that exist by default. And so all I'm doing here is I'm saying only show this button, don't show any of the other buttons. I'm using this ref notation again to say there is a button of this ID defined by this generated tool here. I'm just going to use that. And whatever its definition is, I don't repeat the full definition. But I still have to say what are the parameters for that I'm passing in. And so I'm going to first say what's the input and outputs for this new button here, the generate meta model diagram button that we've added. So that's the button that just loads the meta model diagram into the diagram panel. So again, I'm defining which panel does the button live in, what's the button that we're defining capabilities for, defining the parameters, and I'm saying where does the output go. Now the output goes into the diagram panel. Apologies, this will go away in a moment. The output goes into the diagram panel. The button itself lives in the diagram panel. It's this button. And we're going to say the meta model comes from panel MM. Now you will notice that the parameter is actually called emphatic rather than ecore, but the meta model itself says I'm actually an ecore file. So the types differ, right? And so if it expects an emphatic file, but we give it an equal file, it shouldn't work. But the platform is actually clever enough to work out that one of these tools, in particular this one, I think, provides a conversion function that allows it to go from an equal file, take an equal file and produce an emphatic file. And so when you do something like this, and the platform finds a conversion function that among the tools that you've imported, they will first call that conversion function and then take the result and stick it into the call to whatever function underpins this button. Okay. And so there is some basic translation here so that tools can kind of focus on their core capability, and then the translation between formats is handled reasonably transparently by the platform. And the other button we need to, of course, define is this to diagram button. We need to say what are we going to do when somebody presses that button? And so what we're going to do is, so it's the button in the turtles panel. It's the to diagram button. We're going to generate a diagram, so that's going to go into the diagram panel when it's produced. And the parameters are primarily the input for that comes from the turtles panel. And so that's this one here. Okay. Now, this button already was defined for our specialized editor, so it'll expect to get text in our xtext defined modeling language, and there's a function that was generated as in addition to the xtext editor that knows how to turn that into a diagram, and that's the function that gets called by this button. And so that's literally all that it needs, and it'll produce the output to go into this file. Okay, I think I've put everything in there that I need. So we're going to save this, and going to commit this and push this up to GitHub, and then we're almost ready to try out our activity. So ignore these .project file. This is just my Visual Studio Code thinking it's cleverer than it needs to be. So I'm not going to push any of those. I'm only going to push this activity JSON file. Initial activity configuration feels like a good name for this. We're going to push this up there. And if I've done everything correctly, then in my repository here, we now have this activity file. Okay. The only problem remaining is that there's no easy way for the student to take this and go directly to the education platform with it. And so we're going to add a tiny little trick to make that possible. And what we're going to do is we're going to add a link to our README file that the student can click on that will send them directly to the education platform where they can try out our activity. Okay, so let's go back here, and we're going to open our README file, and we're going to add some text at the very top here. We're going to make it really nicely visible as a quote block. And so the important thing here really isn't the text, it's this part here which defines the link. Okay, and you'll note what I've done is initially something that looks really weird, right? I've given the base URL, and you'll note I've got a provide activities parameter, and after that parameter, what I need to provide is actually the link to the activities JSON file. And in fact, I need to provide the GitHub raw link for that JSON file. And from that, the education platform will be able to work out the rest. But actually, what I'm providing here is a somewhat weird link because it's got this sort of org repo thing in here rather than the actual proper full URL. And I'm going to show you in a moment why that is and how we fix that. The only other thing that I have to do at the moment is I've got to sort of add this other parameter around private repo. Eventually, the platform will be smart enough to work this out for itself. At the moment, you've got to help it and sort of say, yes, this actually will live in a private repo, which means the student will have to authenticate first before they'll be able to access the activity. So we do this, and we're going to add this to our repository in a moment. Now let's get back to why is this weird link. Now, I've already said in GitHub Classroom, what will actually happen is the repository will get copied out for each student, and each student will get their own copy of the repository. And so actually, as a teacher, when I write this, I don't know what the correct link will be for that student because it depends on the name of the repository that GitHub has decided to create for them. And in fact, if the student decides to create a branch within their repository, they might justifiably want to be able to click on that link and get the education platform set up so that it works on that branch rather than on the main branch of their repository. And again, I wouldn't know what the name of that branch is, etc. Right? And so I can't put a proper link here. What I'm going to instead is I'm going to add a little action to a little GitHub action to my repository that allows that allows GitHub to rewrite the README file every time a new branch is created, or in fact, when the repository is initially created, and to make sure that that link is the correct link. And this is something that Antonio Garcia Dominguez sort of built originally, and that we've sort of been reusing ever since. So I've got to really thank him for building the original version here. So what we're going to do is we're going to go into our GitHub folder and the workflows folder, And in there, we're going to create a new, a new additional workflow, which is really very straightforward. It's a workflow that runs on the creation of a branch or the repository, but also if we ask for it to be run explicitly. And all it does is it's going to clone the repository and it's then going to use SEDs to do a rewrite, to do a regular expression, a rewrite over the repository, and it uses these nice variables that GitHub provides to actions to insert the correct repository name and the correct branch name, so that we construct the correct link for this activity file, and then we commit that back to our repository. Okay, so let me actually commit both of these things, and then we should be hopefully ready to try out our activity. So what did I know? That link from README. Okay. And now, hopefully, we should be able to try this out. Now, my new action won't run automatically. So at the moment, the link still, if you look at the bottom of the browser here, you'll see that's still the weird org repo link. So for this repository here, I'm going to have to run my new action manually. But because I've said that's a possible trigger, I get this additional button here. So I'm going to run this workflow, and there it is running. So hopefully it'll get started. I'm going to cancel the GitHub Classroom workflow because that's not going to do anything much anyway. And so this is now currently running. And now it's finished. And so hopefully I get this new commit that the action has just committed for me. And hopefully that also means that this link is correct. So if I look at the bottom here of the page, then I see that it's correctly inserted the repository name and the branch name. So I'm going to click on this link now and open this in a new tab, and I'll sign in. And hopefully, if I haven't made any mistakes, then we'll see our activity momentarily. That looks promising. Now, you will notice that in the menu on the left-hand side, there's only one entry at the moment, even though we defined 2 activities. That's because the second activity, the platform has been able to recognize that it can't actually do this yet because we haven't generated the editor. And that's because, again, we said that for the editor generation, that's the target activity. And we're using the URL rewriting in there as well, which also means it can recognize that it doesn't have all the bits and pieces yet. So the first thing we've got to do is, we have our grammar here. We could edit this if we wanted to. But importantly, we now click on this button, and this is the button that we defined here. But that will trigger the action that we defined here. It's in the Xtext panel. It's the action button, and we'll pass it this grammar and say, can you go away and generate the Xtext editor for us from that? And so if we click on that, and grab a cup of tea, it's going to take a couple of seconds here to do. You can see in the console already the feedback coming back from Xtext, and in the top right corner you will see there's a little notification here that says we're currently building this editor. We're doing stuff. Takes a little longer because it's also generating the web front end for it, so it takes a little longer than doing this into straight Eclipse. We've got to wait a little bit longer, but we'll get a notification when it's done. While this is doing its thing, I'm going to just open the Teams window and just ask whether there are any questions at this point. You still seem to be all with me, so that's a good sign, I guess. Are there any questions at this point? No. Okay, so I've clearly stunned you into silence. Doing this. Now, we're finished. It's telling us it's been successful. That's good. And we now have this additional activity here as well that is worked out. We can now run, and we can now do so. If I click on this, that will make that editor available. And again, it's important, every student who does this, or in fact, if the same student does this in 2 different browser tabs, they'll get a new dedicated instance of this editor for themselves, and it'll be exactly what this grammar defined. So if they've made any changes in this window, even if they're not in the repository, this is the editor that they will get. They could click on save and it would send a commit back of their grammar, but again, we're not going to do this right now. So if I click on this, by the way, when I click on sign in with GitHub, normally I would see an authentication request also from GitHub, but because I've done this a few times already, GitHub's remembered who I am and isn't asking me every time. Now this is the editor that we defined, and we have a panel here with the actual Xtext editor, and we've got this diagram panel here, and we've got our button for generating the model diagram, and we've got a button for showing the meta model here as well. So let's see whether these work, whether we've done the right thing. So if I click on this, hopefully this will produce a diagram of the meta model for me, and it'll show me the meta model for my language. And if I click on this, this should hopefully show me a diagram of the model. So this takes this, passes it, and shows me the object diagram that corresponds to the instance of the meta model that I've just shown. So this is the sort of first basic activity that we can build, and that we've built now. Now, the next thing I wanted to just briefly show is that this actually now also works from the GitHub Classroom here. So if I take this invitation URL and I give it to a student, they can go there, they click on this, and they can go, okay, let me do this, and they can accept this assignment. So if they do that, Xtext goes away and creates a copy of the repository. GitHub goes away and creates a copy of the repository for them. So eventually it'll have done this, and you see it's created a new repository in this organization for them, and it's named it using my GitHub ID. So if I go there, I've now got all the links, and you can see that initial action has already run, and it's rewritten the README file for me. Sometimes, students are quicker than that, so it helps to tell the students to wait for that rewrite to happen. And so if they now click on this URL, they get to the education platform, but the information in the panels is backed by their own repository. So when they click on save anywhere, they'll actually create a commit in their own repository. Equally, if they were to clone this repository and edit it somewhere else and push that back on here, and then open it in the education platform, the contents of the files that they would see in the panels would be that the contents that's in their own repository rather than in the root repository. Okay, and so they can click on this and they'll again get a fresh instance of this to play around with and to work with. Okay. Now, this is sort of half of the stuff that we wanted to do. No, sorry, this is the wrong one. Let me close this. This is the one. This is half of the activity that we wanted to do. What I've shown you here is basically that we can use a single tool, namely Xtext, and we can build a nice activity around it for our students to build a grammar. They can edit the grammar. They can play around with it. They can generate an editor from it, and they can then try out that editor here, right? So this will give me code completion. It gives me syntax highlighting. In fact, it gives me, I think it gives me scoping as well. Although, assuming that I've provided a scope provider to the Xtext generator, right? And it gives me some error highlighting and all kinds of things like that. So they can play with their language here. What we wanted to do as well is we wanted to also do some combine this together with some ETL, with some model-to-model transformation. So let's have a quick look at how to do that. And let me just see, I don't think I've got a slide, but I don't think it says anything particularly useful, so that's okay. So in order to do that, what we have to do is we've got to extend our activity specification here. Now, we don't have to change anything about the first activity. That basically stays the same. It's just about generating the Xtext editor. So there's currently no capability in the platform that allows you to say, I've already got a generated Xtext editor, can you just run it? You've kind of got to start from an activity where the student generates their own instance of the Xtext editor. That's the sort of current setup of how the Xtext tool works. But of course, you could, in principle, create your own language and package that as a tool for the education platform and then make it accessible in that way. But what we want to do today is we want to add to this second activity here, we want to add the capability to do some ETL in there. So let me just make sure that we add all the right bits and pieces. So the first thing we need, obviously, is we need a panel where our students can write their ETL code. Okay. Now this panel type of panel is defined by the Epsilon tools, naturally. And we're going to just add this to our list of panels here. And so we're going to add a panel for the ETL rules. We're going to give it some caption, something to put in the title. The ref is ETL, so that's defined, as I said, by the Epsilon tools here, and that allows us to the students to write ETL code in there. And we say we actually already have a file pre-prepared that contains some basic ETL already for the students to play with. This could be an empty file, or it could be a file where you've already provided part of the transformation. In our case, it's actually a transformation that does some basic copying that the students may have to do something with to do something more useful. The ETL panel provides a button, a little run button to run the transformation. And so we need to obviously then say, okay, for this run button, what should happen when we run it? So let's do that. So we've got to add an action for that, and it's the source of that action is obviously the panel with the ETL rules in it, and the source button is called, funnily enough, again, action button, which is not particularly inventive. We've got to provide some parameters, and we've got to provide some output for it. And in fact, we're going to provide two kinds of output. We're going to provide an output which is where the actual result from the transformation needs to go, and we're going to provide a console to be used for displaying any additional messages and error messages. Okay. Now, let's start with the parameters. We need to provide the actual transformation program. The parameter here is called program. Now that's easy, right? So that's the thing in the ETL panel. So we're going to just say take that from that panel. We've got to also say provide the model that we want to transform. Okay, we've got this. This is the thing that's in the panel turtles. That's the actual model that the students are currently writing, right? So the parameter is called XMI. And again, you will notice that ETL actually expects this to be an XMI, but we've only got it in whatever language the student has defined. But luckily, when Xtext generates the editor, it also generates the tool, which has a conversion function to go from that language, from the turtles language in our case, to XMI. And so that will be called transparently by the education platform before it calls this action. Okay. ETL also needs to know the source and target meta models, and the Epsilon guys have decided that these will be provided using emphatic. Okay, we've got conversion functions to go from equal to emphatic, so that's okay. And they and the source they've decided is called, the parameter is called emphatic, and the target they've decided is called second emphatic. Now that, you know, those parameter names could potentially be improved, but this is what it currently is for the Epsilon tool. It kind of goes back to that these tools come sort of directly from the Epsilon playground, where the structure was a little bit more rigid in terms of parameters and parameter names. And that's all we need, right? But I've sort of lightly put panel MM here, which we have because that's the meta model of our turtles language. And in fact, it turns out that our ETL transformation here at the moment just takes a model in the turtles language and produces a model in the turtles language. And so it's okay to just reuse this for both the source and the target. Obviously, if we were to ask the students to write an ETL transformation that goes from one meta model to another one, then we would have to provide a different meta model here, which means typically we would load by providing an additional hidden panel up here. Now, where are we going to put the output, and where are we going to put the console contents? Well, we haven't got any panels for this. We've got to actually create those panels first, right? So we've got to have a console panel. Let's say we're going to call this panel console, and we're going to want another diagram panel where we can put the target model. We're going to call this panel target model, but we've got to create these panels so that we can actually use them. Okay, so that means we've got to create 2 more panels up here. Let me make my life a little bit easier here. Copy these across because their definitions really are kind of boring. So the target model is a simple panel of type EMF graph. We've seen that already. That's a panel that can hold a diagram. And the console panel is a simple panel of type console. Again, we've seen that already. The only thing that remains is for us to actually make sure that those panels are visible. And so we've got to add to our layout some additional definitions. So say, where are we going to show those panels? Okay, so I'm going to add 2 more rows here. So in the top row, we will have what we had before, which is on the left-hand side, we'll have the turtles editor. On the right-hand side, we'll have this sort of generic source model / meta model diagram panel. And then below that, in the next row, on the left-hand side, we will have the panel with the ETL. And on the right-hand side, we'll have a panel for the target model. And in the final row, we will have this console panel just on the left on its own, so that the student can sort of see any output. Okay. And so, again, hopefully I haven't made any mistake in doing this. If I haven't made any mistake, then if I upload this here, can we push this? Oh, well, okay. I've made some changes online because of that makes sense. I've got to pull first, because what this is our activity, GitHub action that rewrote the URL and the README has obviously made a commit online, and now we should be able to push our current changes. And then here we are in the education platform that's based off of our root repository here. And so if I reload this, it will reload the activity file directly from there, and we should hopefully see the changed layout. Unless I've made a mistake, in which case we should see an error message, but that looks promising, right? So you'll see we have our model, we have this diagram thing. These still work as before. So I can, for example, go, this is the model. But now we also have our ETL file here and our console and our target model here. And if I click on the little run button, hopefully, if I haven't done anything wrong, it'll run this ETL. It'll show a diagrammatic output of the result. And in the console down here, it would show any errors or if there are any print statements in here, it would show their output as well. That's all I wanted to show you. So thank you very much for your attention. And are there any questions at this point?